All right, going back to talking about polynomial operations. Not only can we add and subtract, but we can also multiply. And multiplication is written several different ways. So remember that we know if we see back in middle school and elementary school, if we saw the little X, that meant multiplication because that was our time sign. And then as we moved closer to high school, we saw the little dot. Okay, it's not a very good dot, but we could see a dot, and that would mean times. Or if we saw two letters right beside each other, or a number and a letter right beside each other, like if I said 3y, that meant 3 times y. So we may see multiplication written a couple of different ways. So as we look at this first one says that we are going to do h of x times, using that little elementary and middle school time sign, k of x. So that means that we will take h of x, which is negative 7x minus 2, and we will multiply by k of x, which is our x squared minus 4. And we don't need a sign in between them because it's multiplication. We usually in high school write multiplication with the little parentheses. All right, so there are a couple of ways you can multiply. You could go through and you could FOIL. You could use distributive property, whatever you want to do. Or you could actually go through and use the box method. So I tell you what, on this one, I'm going to distribute. On the next one I'll use the box method, and then you can decide which one you like. So if I'm doing distributing here, that means I'm taking the first number in the parenthesis and multiplying it to the first number in the second parenthesis, and then the second number in the second parenthesis. If there were more numbers, I would distribute it to all of them. So I'm saying negative 7x times x squared, which is negative 7x cubed. Remember, when you multiply, the exponents add. Negative 7x times negative 4, because that minus is like a negative. Negative times a negative is a positive. And then 7x times 4 would be 28x. And again, if you need your calculator, use your calculator. Then we'll take the second number in the parenthesis and we'll distribute it. That's a negative 2 because the minus is like a negative. Negative 2 times x squared is negative 2x squared. And then negative 2 times negative 4 is a positive 8. And once you have multiplied everything, because if there were more numbers, you would continue this process with the more numbers, you will look to see if there are like terms. And so remember, when we do this, we want to make sure we start with the highest exponent. Highest exponent is x to the third. So we have a negative 7x to the third. Then we have an x squared as our next one. And there's not a like term for it. So negative 2x squared. Then we have the plain old x, so plus 28x. And then we have our constant of 8. So there were no like terms, but we did need to rewrite it so that it started with the biggest exponent. All right, let's take a look at the second one. This also means multiplication. HG, because they are right beside each other, that means H times G. Now, they could have put a little dot in between them. I can't get my little dots to show up very well. But, again, multiplication. So, we are multiplying H, so our negative 7x minus 2, times G of x. So, our 4x squared minus x minus 5. And we could distribute, so we could go through and say negative 7 to that, negative 7 to that, negative 7 to that, and then negative 2 to each one of them. Okay, so we could distribute kind of like we did on the last one. But this time I'm going to use the box method. So the box method says that we will draw a box. And since there are two terms in the first one, I'm going to make that go down the side. Since it's the shorter side, I'm going to put negative 7x and then negative 2. And I'm going to draw a line to split those two terms. And then since there are three terms in the second parenthesis, I'm going to make that go across the top and say 4x squared, negative x, and then our negative 5. And so that goes through and puts each of those terms kind of in their own separate little space. And then what we'll do is we'll use the box to guide us in multiplication. The first box says negative 7x times 4x squared. Well, negative 7 times 4 is negative 28. X times x squared is x cubed. And then we'll go to the second box. This one says negative 7x times negative x. Well, a negative times a negative is a positive. 7x times x is x squared. And we can put a plus sign if you want, or you could just leave it and say, hey, I know that's positive. Whatever works for you, it doesn't matter to me. Third box across the top says negative 7x times negative 5. Negative times a negative is a positive. Again, you can put the plus if you want to. 7 times 5 is 35. And then they had an x, so we'll just put an x. It's only a single x since they didn't both have one. We go down to the second row. On the first box on the second row, we have negative 2 times 4x squared. Negative times a positive is a negative. 2 times 4 is 8. And then we have our x squared. And then the second box, negative 2 times negative x. Well, negative times a negative is a positive. 2 times x is 2x. And again, you can put the plus sign if you want, or you could leave it off. I'm going to put them. And then our last box, negative 2 times negative 5 is positive 10. And what I like about the box method is that most of the time when you're done with the box method, you will see your like terms on diagonals from each other. So I only have 1x cubed, so negative 28x cubed. Both of these are squares, so I'll combine those. And they're on that diagonal, which makes it easy for me to see them. Negative 8 plus 7 is negative 1x squared. Now, you can write the 1, but I'll tell you when we do something that is self-graded, the 1 is not typically there. So instead of writing the 1, I'm just going to say negative x squared. We know that that 1 is there. It's just invisible. All right, moving on to x. We have positive 2x and positive 35x. So that gives us positive 37x. And then our constant is all by itself as a positive 10. And that would be our answer. Notice again, starting with the highest exponent, working our way down to the constant. And anything that has a 1, like our x squared here, the 1 is invisible. All right, so what if we had something that looked like, something that looks like f, and then it has the little dot, g, and then of x. So that little dot, remember, is like a time sign. They could have written it as just fg of x, or they could have written it as f of x times g of x. And I'll be honest, they really could have written it as f of x and then the dot, and then my dot's really tiny, times g of x like that. Any of those would be acceptable. But they've written it this way. So all of that means multiplication. So that means that we are going to multiply f of x, which is our 8x squared minus 3x plus 9, times g of x, which is our 4x squared minus x minus 5. So it just told us where to go. I'm going to use the box method. I tend to when I have the ones that are this big. Since it's a 3-term by 3-term, I'm going to make my box kind of big so that I can have 3 in each direction. So I'm going to take the first one and go down the side and say 8x squared minus 3x plus 9. And then I'm going to do my second one across the top. I'm going to change the color so it doesn't run together. 4x squared minus x minus 5. All right, and then I'm going to go through and I'm going to multiply. So in that first box, 8x squared times 4x squared would give us 32x to the 4th because we're adding those exponents. 2 plus 2 is 4. All right, going through to the second box in that row. 8x squared times negative x is negative 8x to the 3rd because we had 2 x's here, 1 here. Going to that last box, 8x squared times negative 5 would give us negative 40x squared. All right, on the second row, negative 3x times 4x squared would give us negative 12x to the 3rd. In the middle, negative 3x times negative x would make a positive 3x squared. Because again, remember, we're adding the x's. Going back are the exponents. Going to the last box on this row, we have negative 3x times negative 5, which is positive 15x. And then in our last row, positive 9 times 4x squared would give us positive 36x squared. In the middle, 9 times negative x is negative 9x. And then 9 times negative 5 is negative 45. And then we would have to go through and add our like terms. Again, the reason I like the box is that my like terms usually end up on a diagonal. So my biggest exponent is 32x to the fourth. And then I have my thirds. Negative 12 and negative 8 give me negative 20x to the third when I add. And then I have a whole bunch of squares right here in the middle. I'm going to grab a different color for them. I've got positive 36, positive 3, and negative 40. You can certainly use your calculator for that, or you could just add them. I know these two add to give me 39, and then I have a negative 40, which gives me negative 1x squared. Now remember that we're going to ignore the 1. We're going to leave it invisible, so I'm not going to write that 1. And then going back, we have our negative 9x plus 15, which was plus 6x, and then our minus 45. And there's nothing special about the one that's in pink in the middle. It's just there were so many of them. I didn't want my colors to run together. So our final answer is 32x to the fourth minus 20x to the third minus x squared with the invisible 1 plus 6x minus 45. And again, you could have done distributive property with this. To me, distributive property gets really long with these. So the box method helps keep me a little more organized.